Hi, my name is Xiangci Li. I'm a PhD student at UT Dallas. I'm honored to present our paper, CORWA, a Citation-Oriented Relative Work Annotation Dataset today at NAACL 2022. As NLP researchers, we must perform a literature review under the relative work section to distinguish our work from the prior works. However, writing a relative work section is labor-intensive, while papers in the same fields are likely to repeatedly review a similar set of prior works. This motivates us to automatically generate relative work sections based on the rest of the paper and a list of reference papers. Previous extractive relative work generation simply concatenates the salient sentences extracted from the cited papers. The abstractive approaches aim to reconstruct the masked citation sentence given a citation context that surrounds the target as well as the abstract of the cited paper. However, prior works, including extractive and abstractive ones, mostly oversimplify relative work generation as a general summarization task by generating relative work sections using sentence-level models, while this sentence-based approach ignores the varying forms of the text in the relative work section. For example, the writing style may vary into descriptive and integrative styles, as pointed out by Dr. Tokyo Jaka in a series of studies of literature review writing. In this work, we propose a citation-oriented relative work annotation scheme for a linguistically motivated relative work generation framework. We collect a CORWA dataset and propose a strong baseline model that automatically tags the CORWA annotation scheme on massive unlabeled relative work section text in order to provide abundant training data for relative work generation. We then show that citation spans are better target than citation sentences for abstractive relative work generation. Finally, we discuss a novel framework for human-in-the-loop, iterative, abstractive full relative work generation. One of the key ideas of our CORWA scheme is to distinguish the information source that text is derived from. CORWA consists of three interrelated tasks: discourse tagging, citation type recognition, and citation span detection. For each sentence, we assign a discourse label. We first aim to distinguish different styles of citations. We distinguish summarization sentences that describe prior works in detail and narrative sentences that mention each prior work in high level. We also distinguish whether a single document or multiple documents are cited. Another important point about discourse tagging is that we distinguish citation sentences and non-citation sentences. Citation sentences information mainly comes from the cited documents, and the non-citation sentences information is originated from the authors of the current work. We believe this is important for the relative work generation task. For each citation mark, we distinguish whether the author cites a work for really talking about it, which we call it dominant, or simply cited for reference. Usually, summarization sentences contain a dominant citation, while narrative sentences only contain reference-type citations. We also annotate the influenced span of each cited work. This span can be as short as a few words for reference-type citations, or as long as a few sentences for dominant-type citations. In this artificial example that illustrates the label set of CORWA, the first general topic sentence does not contain any citation. Then a narrative sentence cites a few reference citations with short spans. Sentences 4 and 5 mostly entirely describe the prior work in detail. Note that in line 5, the reference type span is nested in a longer dominant type span. Finally, a reflection sentence ties the relative work back to the current work. Additionally, we define a dominant type span if it contains a dominant citation. Otherwise, it is a reference type span. We iteratively train a model to assist the annotation process, asking two annotators to correct the model's prediction. Our data has strong inter-annotator agreement on all tasks. The joint distribution of discourse tags and the citation span types in the table shows that the most frequent patterns are single sum with dominant citation, multi-sum with dominant citation, and narrative sentences coupled with reference type citations. These numerical results are consistent with our intuition. We analyzed the writing style of related work sections in CORWA. Similar to the descriptive and the integrative literature reviews proposed in information studies, we have summarization and narrative sentences. This parallel plot shows that all three types of paragraphs exist. Summarization sentences only paragraphs, narrative sentences only, or paragraphs with a mixture of both types. Next, we develop a joint related work tagger to perform the CORWA annotation automatically. This figure is the model architecture of our joint tagger for CORWA. We use multitask learning to train a single language model on three tasks of CORWA. We use the train model to predict unlabeled related work sections and use these distantly supervised data as additional training data. Our tagger can achieve a high performance, which means that it can become a reliable tool for generating related work generation datasets. Next, we show citation spans as an alternative to sentences. We use different citation tags as queries to retrieve relevant sentences from the cited abstract based on the Rouge recall score, as is commonly used in prior works. The figure shows using reference type spans as queries significantly outperform citation sentences. Let's move to the actual related work generation task. As the figure shows, there's an obvious mismatch between citation spans and the sentences. Dominant type citation spans usually cover multiple sentences, while reference type spans only cover a fraction of the sentences. By definition, citation spans are the exact text derived from the cited papers. Accordingly, this significant mismatch results in information loss for reference type spans and information leak for dominant type spans in the citation sentence generation task according to the previous task settings. Instead, we work on span-based related work generation. We first pre-train a sequence-to-sequence model, long-former encoder-decoder on a series of tasks. We then concatenate all inputs as a long string and feed it to LED. The generation target is simply the ground truth citation span determined by CORWA. We also use distantly labeled related work sections tagged by the joint tagger previously introduced for training. The automatic evaluation results show that overall span generation has a similar performance as sentence generation. Note that the performance of span and sentence generations are not directly comparable due to their different generation targets. According to our human evaluation, gold spans have a significantly lower relevance scores because they contain information derived from the body section of the cited papers that neither the model nor the evaluators see. The reference sentences have lower relevance scores than spans, which confirms that citation spans contain more focused information. Last but not least, we discussed the roadmap towards the full related work generation. So far, there's no prior work addressing the ordering of the extracted or generated sentences, nor producing rhetorical sentences to smooth the transition between citations. We suggest a bottom-up, iterative approach to generate full related work sections by performing citation span generation, aggregation and rewriting of the citation spans to blocks in either the summarization or narrative style, and further into paragraphs by generating transitions and reflection sentences. We suggest implementing it in a pipeline fashion because this mitigates the challenge of long text generation since auxiliary inputs, such as citation functions, may vary for each stage of generation. And most importantly, this enables human-in-the-loop to significantly prune the search space and reduce the error propagation caused by the pipeline design. That's all for my presentation. Thank you.